All right, so here we're looking at inverse variation. So let x and y denote two quantities. Then y is inversely proportional to x, or y varies inversely with x if there's a non-zero number k such that y is equal to k divided by x. Because if we look here, this is the inverse of this. It's 1 over the y if we said they were inversely proportional based on some k value. So let's go ahead and write that back up here. Y is equal to k over x. So y is inversely proportional to the x, or it varies inversely with x. Suppose y is 6, x is 4. So we're going to plug in 6 and 4, and then we want to find when x is 8. Well, we have to find k first. So if we plug those in, like I said, we're going to get k is equal to 24. So really, our equation now is y equals 24 over x. Now they want us to know what is y when x is 8. Well, if we plug 8 in for x, what's y going to be? Well, y is going to be 3. Okay, so we just plug it in and we get y equals 3. And so that is our value when x is equal to 8, y is equal to 3. And that's the inversely proportional because remember, y equals the 24 over x. And so these are inversely proportional based on that constant. Now, if we had a different constant here, it wouldn't be y equals 3. It would be something else. So it's not always going to be the same number. It all depends on your constant of proportionality and then what type of proportion it is. All right, so now we're supposed to determine whether the data in each table represents direct variation, inverse variation, or neither. For direct and inverse variation, find the equation. Okay, so here, if we go from 3 to 12, well, 3 times 4 is 12. 7 times 4 is 28. 9, wait, yeah, 9 times 4 is not 36. And then that should be 36. I think they have a mistake here. I'm thinking because that's times 4, that's times 4, that's times 4. I'm betting this is supposed to be 36. I haven't actually looked at that to notice that, but I bet this is supposed to be a 36, or that's supposed to be an 8, one of the two. And so I would say yes, it's a direct, and it's going to be y equals 4 times x. Okay. Now here we have 5 to 12, 10 to 6, 12 to 5. So this is some kind of a weird situation. I'm not sure what that one is. So it's either going to be inverse or neither, I think. Now here, what about this one? Well, 6 times 8 is 48. 11 times that is going to be 11 times 6 is 66. Now 6 times that should be 84, and 6 times that should be 126. So this is a direct again, and this is y equals 6x. So this is the only one we really just looking at don't know for sure. So we would have to do something to figure that one out. So let's first make sure we have A and B right. Well, neither the product or okay, so they were meaning that this was not a mistake. It was actually supposed to be a 32 there, so that is neither. But if that was a case where that was a 2 or a 6 rather, then it would be a direct. But because it's not exactly the same every time, and that one's the oddball out, then it is neither. So this is a case where I wasn't sure if they made a mistake or they just wanted to neither. So that's the key to pay attention to there. All right, how about the next one? Well, this one's increasing and that one's decreasing. So that makes sense. It's some kind of inverse, which is what we were thinking. And so what we need to do now is we had to figure out what it is. And so you had to plug in those values to figure out what it is. And so you had to do, 5 is equal to k over 12, multiplied by k is equal to 60. And then we can check this one here. We could do 15 equals k over 4, and then k still here is 60. And we have to do that for all of them because here, if we just had done the first couple and the last one, yeah, that does. But then this one is one that threw me off because, well, maybe they did a typo, or in this case, it was just neither. And this one, it looks like all of them multiply together to 60, so that would be okay. And then this one, all of them work, so that was a direct, so that was a 6x. Okay, so that's how we need to look at those as far as we go. And I guess we're going to have to assume that they don't make a mistake on typos. All right, let's stop there and we'll come back for some more.